Good morning to all. Today we are going to see about problems related to beta and gamma function. In the last module we had discussed about what are the definitions of beta function, gamma function, and the relation between the beta and gamma function, some properties of beta function and some properties of gamma function, and an important recurrence formula for gamma function. Okay, so today we are going to mainly solve problems, these 5 problems using this relation between beta and gamma function. So what is let us recall what is the relation between beta and gamma function. So it is nothing but beta of m comma n. This notation is called as beta of m comma n, which is equal to gamma of n divided by gamma of m plus n, where m is a non-negative integer, n is also non-negative integer. So hence m plus n is automatically it is a non-negative integer. So beta of m comma n, just for information I am recalling the definition, that is integral 0 to 1 x power m minus 1 1 minus x the whole power n minus 1 dx, and gamma of m is nothing but integral 0 to infinity e power minus x power m minus 1 dx. So now we are going to first solve problem number 1. What is it? It is, let us evaluate the integral 0 to 1 the integrand is x power m log of 1 by x the whole power n dx. Students may thought like that, that is here the limit is 0 to 1, so this may be a type of beta function, but it is not like that, because if we give some substitution, why we are going to the substitution method? Because if we compare this integral with these two functions, that is beta function and gamma function, we can see that this is not in any one of these two types. So we have to change, or we have to give some substitution to this problematic number function. Who is the problematic function here? Log of 1 by x. So we have to give substitution to this log of 1 by x, so that we will make this integral into these two types of integral, that is beta function or gamma function. So always in the substitution method we will go to the function which will be problematic one. So let us first take that integral as some I. So let I is equal to integral 0 to 1 x power m log of 1 by x the whole power n dx. Now I am going to use the substitution method. So take t is equal to log of 1 by x. Now t is a variable depending on x. So our aim is to change this dx into another variable dt. Okay, so what are the changes we should make? We should change the limits, and we should substitute wherever x, we have to make it as t, and we should change this dx also. So first we will find what is x. If t is equal to this one log of 1 by x, then this log, if come this side, this will be e power t. So the right hand side will be 1 by x. Okay, so now from this we observe that x is nothing but 1 by e power t, that is nothing but e power minus t. Okay, now we will calculate this dx. Then what will be your dx? So dx is nothing but derivative of e power minus t. What is derivative of minus t? So exponential always getting the same derivative, no? So e power minus t will be having derivative e power minus t. So d of e power minus t is e power minus t, and we have to concentrate on the coefficient before the variable. Here variable is t. So before the coefficient, what is the constant? Minus 1. So it should be come before. So dx is nothing but minus e power minus t into dt. Okay, so dx is nothing but minus e power minus t dt. and then we have to calculate the limits. What are the limits? So the limits will be, so x, what are the limits of x? 0 and 1. So now calculate limit of t. When x equal to 0, what will be your guess? If x equal to 0, then t will be infinity, because e power minus infinity will give you 0. Okay, we should not say like that. That is, if t tends to infinity, this factor will goes to 0. If x equal to 1, then what will be your answer? Then it will be 0. Okay. So these are the limits. Now let us going to substitute these things in this integral I. So now I will becomes integral. Here when 0, the limit will be infinity. When 1, it will be 0. So x, what is x? X is nothing but e power minus t, the whole power. So here x power m, no? So that is e power minus t, the whole power m. So what is log of 1 by x? For that fellow only we are substituting t, no? So that will be t power n. So what will be dx? Dx is nothing but minus of e power minus t dt. Okay. So now we are going to collect the terms. So this is nothing but, if in having some constant in the integrand, we can take it outside. So this integral will becomes minus of integral infinity to 0 e power minus, here we have one formula. What is that? If a power m, the whole power n is nothing but a power mn. Okay. So using this formula, what will be this? This will be nothing but e power minus mt. So this is nothing but same as it is, and minus we already take it outside. So another term is e power minus t dt. So now this is nothing but integral. So before that we can use one formula. What is that formula? That is a property for finite integrals, definite integrals. What is that? If you multiply or if you change the order of the integration, it will, minus sign will come outside. Already there is a minus sign, so this will become integral 0 to infinity. Okay, now we have to collect this exponential terms together. So e power minus mt minus t into t power n dt. So now this integral is nothing but, again we are collecting the coefficients. So e power minus of m plus 1 of t into t power n dt. You thought, so now you can guess, no? This is nothing but a type of gamma function. But here the only problem is the exponential in e power minus x won't be there. That is only one variable will be there and the coefficient will be 1. But here the coefficient is m plus 1. So again we are going to give substitution. So for that, let us take this sum as I1. So I1 is this integral. So I1 will become, I1 is nothing but integral 0 to infinity e power minus of m plus 1 into t, t power n dt. So in this, our problematic member is this m plus 1. No, so we are going to substitute, put y is equal to m plus 1 into t. Then what will be I, if we substitute t equal to 0, the limit will not change. If t equal to infinity, the y also will have infinity limit. Okay, so now we have to calculate what is dt. So what is dy? Dy is nothing but m plus 1, because it is a constant, it will not affect by the derivative. So t will becomes dt. So dt is nothing but here dy by m plus 1. So which is equal to dt. Now we give this substitution to this I1 integral. This integral will become, limit will be same, e power minus y. The t power n is nothing but what? It is nothing but, so we have to, what we have to get, what is t? What will be your t? So t is nothing but y divided by m plus 1. So if you substitute here, we will get y divided by m plus 1 the whole power n into dt. Okay, so now you can somewhat observe that this is nothing but a type of gamma function. So now we have to expand this expression. Now we get this is nothing but integral 0 to infinity e power minus y. This is nothing but y power n divided by m plus 1 the whole power n dt. Sorry, I forgot one thing, that is we have to replace this dt. No, this is nothing but dy by m plus 1. So now this becomes e power minus y power n m plus 1 the whole power. Here two terms, m plus 1 the whole power n, m plus 1. So it is m plus 1 the whole power n plus 1. So now our integral reduced to a type of gamma function. So now what is your I1? I1 is nothing but we are taking this constant outside, that is m plus 1 the whole power n plus 1. So the integral is integral 0 to infinity e power minus y power n dy. So actually our problem is this one. Now we make it as a type of gamma function because we know some formulas related to gamma function. That's why we are changing this given problem into a beta or gamma function for our convenience. Okay. So now you compare this integral I1 with the gamma of m or gamma of n. If it is instead of m, if you substitute n, the x power m is nothing but x power n minus 1. That's all. There is no issue. So if you compare this with the gamma function, you can observe that the power of y, the variable power will be, there is n minus 1, here n. So for that I am going to do little calculation. What is that? I think you may guessed. What is that? We have to add and subtract 1 in the power of y. So there is no change because 1 minus 1 is 0. Anything plus 0 is the same number. Okay. So now this is nothing but kind of gamma function. So first we are writing that constant m plus 1 the whole power n plus 1. This is nothing but gamma of n plus 1. Now we are going to use the recurrence formula. What is that? We already mentioned in the last module. The gamma of n plus 1 is nothing but n factorial. So the answer will be n factorial divided by m plus 1 the whole power n plus 1. So now we got the answer for the integral. What is that integral I? I is nothing but integral 0 to 1 x power m log of 1 by x the whole power n dx is nothing but the answer. It is nothing but a rational because it is a type of real numbers. It is a finite number. Why it is finite? We know that n is an integer, so n factorial is always a finite number, and m n are integers, so this is also will be finite number. If we divide two finite numbers, we will get a finite number only. So therefore this is a answer for this integration. Initially we will worry about this log of 1 by x and so on. So in every problem, if we solve just like that the problem, we cannot have the solution. So we have to try to convert it into a easy way or a standard method to get a correct answer. Okay, or we can use any easy method. This is one type of easy method, that is beta and gamma function are used to solve this kind of proper and improper integrals. So okay, shall we move to the next problem? So our next problem is evaluate integral 0 to pi by 2 sin power 7 theta cos power 5 theta d theta. If you saw the last module, you know that this is nothing but a type of beta function. What is that? So beta of m comma n is equal to two times integral 0 to pi by 2 sin power 2m minus 1 theta cos power 2n minus 1 theta d theta. So now you can got an idea. What is that? This is nothing but exactly a type of beta function, having some constant in the power, cos and sine. So let us compare these two integral. Before that we will do some little calculation. What is that? That is 1 by 2 times beta of m comma n is equal to this integral. Actually, in the last module also we solved one problem. I am solving this problem to get an idea to solve the third problem. That's why I am repeating, and I just changing the integers 7 and 5. Okay. So now we are going to write this formula somewhere, because I am going to use this in the last two problem 3 and 4. So therefore this integral 0 to pi by 2 sine power 2m minus 1 theta cos power 2n minus 1 theta d theta is equal to what? 1 by 2 times beta of m comma n. And we know that there is a relation between these two values. So we will do after some time. So okay, now 1 by 2 times beta of m comma n is this integral. Now compare this with the given integral. So what will you get? So by let us take this as I. So let us take this as equation number 1. If you take this as equation number 2, so by comparing 1 and 2, we get 2m minus 1 is equal to what? 2m minus 1 is equal to 7. 2n minus 1 is equal to 5. And this integral I is nothing but 1 by 2 times beta of m comma n. Here, what is your m? From the easy calculation you can see that 2m minus 1 equal to 7 becomes 2m equal to 1 plus 7, that is 8. So if you divide by 2 you will get m. So what is m? M is nothing but 8 by 2, that is 4. So m is equal to 4. Okay, similarly if you solve this, what will you get? So this will give you 2n equal to 1 plus 5 6. So this will give you n equal to 3, because 6 by 2 is 3. So here n equal to 3. So now you may wonder that the given integral is nothing but 1 by 2 times beta of 4 comma 3. So I is equal to 1 by 2 times b of 4 comma 3. So now we can use the relation between beta and gamma function to get the answer. How we'll do that? Let us see. So now I is equal to 1 by 2 times b of 4 comma 3. What is that? By using this relation, this is nothing but gamma 4 gamma of 3 divided by gamma 4 plus 3. So this is so 4 plus 3 is 7. Again we are going to use that recurrence relation. What is the recurrence relation? Gamma of n plus 1 equal to n factorial. Now you tell what is gamma 4. So gamma 4 can be written as, for your to make you a clear idea, I am writing this 4 as 3 plus 1, 3 as 2 plus 1, 7 as 6 plus 1. Now tell me what will be the answer. This gamma of 3 plus 1 is nothing but what? It will be 3 factorial. And this is nothing but gamma of 2 plus 1 is 2 factorial by this formula. And gamma of 6 plus 1 is 6 factorial. Now we all know about the factorial formula. What is that? So for your information, I am writing the formula for n factorial. What is that? N factorial is nothing but 1 into 2 into 3 into and so on n. Okay. So now we use this formula. If you expand this, what will you get? So 1 by 2 times 3 factorial can be written as 1 into 2 into 3. 2 factorial can be written as 1 into 2. 6 factorial can be written as 1 into 2 into 3 into 4 into 5 into 6. So here having numerator and denominator, automatically our mind will expect to cancel out some numerator terms and denominator. So if we observe this 1, 2, 3, 1, 2, 3 will get cancelled, and this 1, 2 times, this 2 times of. So what will your answer? So 1 by 2 into numerator, every 8 term will get cancelled. So 1 into 1 is 1. So here denominator 2 5s are. So 2 into 5 into 6. So this is nothing but 1 divided by 2 into 5 into 6. Okay. So now for you this is easy, no? What is this? 4 2 2s are 4, 4 5s are 20, 26 are 120. So the given integral value is nothing but 120. So this is because of the relation between beta and gamma function, and using a factorial formula and the recurrence relation of gamma function. Okay. So now let us solve the third problem. So what is your third problem? So the third problem is nothing but evaluate integral 0 to pi by 2 sine power 10 theta d theta. So again from the limits itself you can guess that this is a type of beta function, isn't it? So let us use this formula which I already mentioned to you, that, and you have some doubts. Here there is a cos power 2n minus 1 theta, but here is no cos term. So what shall we do for that? So first we will take this as integral I. Okay. And then there is no cos term, and in mathematics we know that anything power 0 is 1. So we know that here sine power 10 theta into 1, like that we can observe, because anything into 1 is nothing but the same number. So for that 1 I am going to replace that cos power 0 theta. Because of this, is there any problem? No. Isn't it? Because cos power 0 theta is 1. So now we will compare this with this formula. What will you get? I is nothing but 1 by 2 times beta of m comma n, because I don't know m and n, that's why I am using the same notation. Okay. So what is 2m minus 1 from this formula? 2m minus 1 is nothing but 10. 2n minus 1 is nothing but 0. Okay. So m is nothing but, what will you get m? So 2m is nothing but 10 plus 1, that is 11. So m is nothing but 11 by 2. And what will be your n? N is nothing but 2n equal to 1. So n will be 1 by 2. Okay. So we found m and n. Now substitute here, what will you get? This is nothing but 1 by 2 times beta of 11 by 2 comma 1 by 2. Now your problem starts here, because if you have an integer you can directly use the recurrence relation, gamma of n plus 1 equal to n factorial, but we cannot do like that, but we can use this first, the relation between beta and gamma function. So this integral becomes 1 by 2 times gamma of 11 by 2 gamma of 1 by 2 divided by gamma of 11 by 2 plus 1 by 2. Okay. So that is, this given integral is become like this. Now what is 11 by 2 plus 1 by 2? So while adding two rational numbers, you should be careful on the denominators. Here two denominators, here also two, here same denominator. You can add the numerator as it is. So this becomes 1 by 2 times gamma of 11 by 2 gamma of 1 by 2 divided by gamma of 11 plus 1 is 12. So 12 by 2. So now that I is nothing but what? 1 by 2 times gamma of 11 by 2. I know that value of gamma of 1 by 2 because in the last module we calculated this value. And now what is gamma of 12 by 2? That is 6. So let us take some equation number 1. In equation 1 we know the values of gamma of 1 by 2. What is that? It is root pi. Okay. And let us take this as equation number 2. What will be gamma of 6? So gamma of 6, here 6 is an integer, we can use the recurrence relation. So the gamma of 6 will be gamma of 5 plus 1. What is that? This is nothing but 5 factorial. What is 5 factorial? It is nothing but 1 into 2 into 3 into 4 into 5. So 2 3s are 6, 4 5s are 20. So 2 3s are 6. So it is nothing but 120. So let us take this as equation number 3. So now we have to find out this gamma of 11 by 2 alone. So how will you do this calculation? Now for this we can again going to use the recurrence relation. What is that? Gamma of n plus 1 is, so first we know that gamma of n plus 1 is equal to what? N into gamma of n. So I am going to use this relation to get this value of this gamma of 11 by 2. So now consider gamma of 11 by 2. Now you are going to use this formula. So you have to make this 11 by 2 as the form some n plus 1. Okay. So 11 by 2, how can you make it as? So it is nothing but 9 by 2 plus 1. Now you know that if you take the, so 9 by 2 plus what is that? If you take the cross multiplication, it is nothing, if you may, 1 can be make it as 2 by 2. So 9 plus 2. So 11 by 2. No. So 11 by 2 can be written as 9 by 2 plus 1. Now you are going to use this formula. This will give you 9 by 2 into gamma of 9 by 2. So again we have to calculate what is gamma of 9 by 2. What will be gamma of 9 by 2? As in the previous step, we have to consider 9 by 2 as 7 by 2 plus 1. The same thing. If we change to 7, here 2 by 2, so 9 by 2. Okay. So this will becomes 7 by 2 into gamma of 7 by 2. If you proceed like this, now you can tell the answer. What will be that? Gamma of 7 by 2 will be 5 by 2 into gamma of 5 by 2. So gamma of 5 by 2 will be 3 by 2 into gamma of 3 by 2. So what will be gamma of 3 by 2? So gamma of 3 by 2 will be, proceed as above. It is nothing but 1 by 2 into gamma of 1 by 2. And you know the answer of gamma of 1 by 2, that is root pi. So this will become, so root pi by 2. Now we are going to substitute all these values in equation number 1. What will you get? So 2, 3 and this values you will get. So this I becomes, I is equal to, this is 1 by 2. Gamma 11 by 2 is nothing but what is the first term? So first we will do separately also. So before this, let us calculate gamma of 11 by 2 separately. So gamma of 11 by 2 is nothing but 9 by 2 into gamma of 9 by 2. But what is gamma of 9 by 2? It is nothing but 7 by 2 into gamma of 7 by 2. What is gamma of 7 by 2? 5 by 2 into gamma of 5 by 2. But what is gamma of 5 by 2? It is 3 by 2 into gamma of 3 by 2. What is gamma of 3 by 2? It is 1 by 2 into root pi. Okay, so now if you make it a calculation, this is nothing but 9 into 7 into 5 into 3 into root pi divided by, so 2 power 5. Okay, 2 into 2 into 2, 5 times, so 2 power 5. Now substitute these into this equation number 1. Now 1 becomes, I is equal to 1 by 2 times gamma of 11 by 2, this value. No. So 9 into 7 into 5 into 3 into root 5 divided by 2 power 5 into what is gamma of 1 by 2 by equation 1. So by equation 2 it is root 5. What is gamma of 6? Gamma of 6 is nothing but 120. So now you can keep it this gamma of 5 factor, gamma of 6 as 5 factor also. Otherwise you can cancel out. That is 1 3s are 3, 4 3s are 12, 0. Okay, 1 5s are 5, 8 5s are 40. Let us check, is there any possibility to cancel out the denominator and numerator? I think that's all over. So I will be nothing but 9 7s are what? 63. Root pi into root pi. Root into root, it will be root 5 the whole square. So in denominator 2 into 2 power 5 into what will be 8? 8 is nothing but 2 into 2 into 2 4s are 8. So 4 can be written as further classified. So it will be nothing but 2 power 3. Okay. So now the answer will be, numerator will be, so root 5, root 2 and the square will get cancelled. So 63 pi divided by, what will be the answer? A power m, a power n, like that the formula. So what is that? So a power m into a power n is equal to a power m plus n. If you use that formula, what will be this? 1 5 3. So it will be 9. So 63 pi divided by 2 power 9. Otherwise, if you want, you can calculate this also. This is 2, this is 32, this is 8. You will get a finite answer. Okay. So this is the value of this integral 0 to pi by 2 sine power 10 theta d theta. Actually, if we see this two integrals, we will see this will be a simpler one. But if you do calculation, we may wonder that to get the value of this type of integral is taking some more time. Okay. So now, okay, dear students, I think this is enough for today's session because this will take half an hour also. So we will see in the next module how to solve these two integrals. Thank you.